All right, as I said, these were the two most common missed problems on the quiz. A lot of you got to this point right here where you got negative 5 over 11 and 5, 6. Yes, I know it's not the exact numbers as last week, but this is what you need to do. You need to substitute it in. And then you stopped and didn't do anything else. This, if you stopped here, that's not all of the problem. You have to find the average rate of change. And remember that the average rate of change is the change of y over the change of x. What is that formula? Very good. And that's what you're supposed to do. So some of you, I walked around and you got the right answer. But we didn't do this on the quiz. Some of you did this, y over x, y over x. No, this whole fraction is all of y. This whole fraction is all of y. This is why I tell you to label y1 and y2 to help you out. So it was going to be y2 minus y1 over x2 minus x1. But Miss Santana, that's just a fraction over a fraction. Can I do that? Yes! Yes, you can have a fraction over a fraction in math. You can put it in your calculator. Everyone, how do we put a calculator? How do we put a fraction in the calculator? Alpha y equal, which means that if there was another fraction, what should I push? Alpha y equal again. Okay? You can have a fraction over a fraction. Somebody said, well, you didn't teach us this. Yeah, I did. Just because I specifically did not teach you an example like this, you still need to know how to put the things together. Nothing's changed. It's still average rate of change. It's still slope formula. Nothing changed. Okay? Questions? Yeah.
How do you get 66?
Okay, so when I put it in the calculator, I do, what is that? 5, 6, right? 5, 6 minus negative, oh, need parentheses, negative 5 over 11, 3 minus negative 2. Make sure you put it in your calculator correctly, okay, if you didn't get 66. Good? Let me wait until you're done. Make sure that you put it in right. Good? Okay. All right, let's look at number 2. Number 2. A lot of you, like literally a lot of you got this wrong. You did this second part right. You got 5,100 and then you just stopped. Or you told me it was 5,100 meters per second. It's on the paper. Can you see it? Jahira, sorry, I'm talking to you. Okay, make sure. You put 5,100 meters per second or whatever it is. You can't do that, okay? You still have to use the slope formula. If there is no starting point, if it just says first whatever, the x value is always going to be 0, the first one. The first x value will be 0. And the second x value will be what they tell you, first 12 seconds, okay? Over that interval, that's what that means. First 12 seconds, first 20 seconds is an interval from the start, which is 0, to the end, in this case, which is 12. Start to end. What? What? Do I got like something on my teeth or something? Okay? And then you just do the slope formula. Questions? Are we sure there are no questions? Because when you have your quiz on Wednesday and there's a problem like this, we should all then get it correct?
Yes. Maybe.
Okay. Before I move on, for the review tomorrow, is there anything that I need to address in the review so that this way, and please don't say everything, be specific, so that this way I can model the review so that this way you can have practice. Speak now, forever hold your peace. Alright, then take out the worksheet that I gave you. Take out the worksheet I gave you. Where is my copy? Here it is. Here's Carmel. Everybody have a sheet? Emerson, give it to me. Probably in all the classes, dude. In all the classes to do this. Thank you, sir. I didn't give you guys one? How do I always forget one? My bad. Okay. Are we ready? Okay. So here's the change from level 2 to level 3. The first thing is you're not going to get a graph. You're not going to get a function. You're not going to get a graph. You're not going to get a function. You're not going to get a table. You need to use context clues in order to figure out what your independent, which is x, and your dependent variable, which is y, is in the problem. Okay? 90% of the time is always going to be your x value. Okay? So time, that includes seconds, hours, days, years. All right? Because everything else depends on time. The amount that I drive, or sorry, the distance that I drive depends on how long I'm driving, right? The amount or the total number I pay for pencils depends on how many I buy. So things like each and time, that is going to be your x. The other change from 2 to 3 is that you have to use that information to solve an extension or answer an extension question. So let's start with the first one. Example 1 says a rocket is 1.5 miles above Earth in 20 seconds and is 8 miles above Earth in 2 minutes. Find the rocket's rate over time during this interval. And using the information, find the estimated distance from the Earth the rocket is after 1.5 minutes. So this is a two-parter. All of level 3 is going to be a two-parter. You're going to have to find the rate and then use that rate to answer a different question. So let's look at this problem. The easiest thing to do to start with is trying to figure out your rate. Okay? Trying to figure out your units. Your units. So remember, we have the change of y over the change of x. Given this problem, what are 2 units that we have? Miles and seconds. Miles and seconds. What else do we have? Minutes. We'll talk about that in a second. Okay? We want to use miles per second. And I just gave you the answer. What are my y units? Miles. But I'll explain why in a second. Over what? Seconds. I got that from reading the question. It says rate over time. That word over implies that it is automatically a fraction. That word over. There's another word that implies per. What else is another word? Starts with an E. Huh? and E. Each. There's another phrase. For every. Okay? So make sure you know these context clues in order to help you determine the fraction. Okay? So let's start with what we know. Hi. Video will be up tonight. Which one do we know? Like, imagine we didn't have this here, right? This over time. Over implies fraction, right? What is time in this instance? Seconds. That's why it's my denominator. That's why it's my denominator unit. So then my other units is what? Miles. Okay? Questions? Okay. So, we know that miles is y and seconds is x. So let's look at this. Miles is going to be what? What coordinate?
The Y.
The y. And 20 will be, obviously,
The X.
the x. Very good. So now we have our first coordinate. In order to find our average rate of change, we need 2. What's the next thing we have? Miles and 2 minutes. Can I use this if my units are seconds? No, we have to do what then? Convert. So we're going to need to convert. So how can I convert minutes to seconds? 60 seconds per minute. So what do I need to do? Yes, how'd you get 120? You did not divide. 60 plus 60, but let's use let's say I have 1.754231. 60 seconds times 2. I heard that from a few people. So it's going to be 60 times 2, and that will give me 120. I know we all know that that's 120 seconds. Am I talking too fast? Okay, sorry. So then, this is 120 seconds. What is my next coordinate? 8 and what? Can't hear. 120. Do we see that? Questions? So I have my 2 coordinates. What do I do now? 120 minus 1.5. 8 minus 20. Can somebody tell me what's wrong here? Why? Why? Very good. Did everybody hear Ileana? Okay, that's okay. I will reiterate. So, Ileana said we need to switch these two. And I asked her why. She said because miles is the y value and 120 is the seconds, which is the x value. Okay? And yes, I know I could have corrected at that time, but I know that everybody was thinking that. Okay? Do not write it in order of here. That's what I'm saying. You have to use context clues. So this is 120 over 8. You guys can't see that color, can you? Which means that this is going to be different or not to be. So now what is my slope formula? 8 minus 1.5 over 120 minus 20. Questions? Okay, when you put that in the calculator, you will get 0.065. Is that your final answer? Why? Units. What are my units? Miles per second. That's why you write them first, because they're right there. Questions? For that one, yeah. Ready? Okay, let's look at part B. Part B says using this information, find the estimated distance from the rocket. The rocket is after 1.5 minutes. Can anybody tell me what the first thing I should do? Convert what? Very good. 1.5 minutes into seconds. And that, how do I do that? Nope. 60 times 1.5. Multiply by 60, okay? Yes, I know you get 90. I know you know what it is, but let's say, like I said, what if it was like 1.74321, right? You wouldn't know what the 0.74 is exactly. Okay, Alicia? Okay? All right. Guess what? We need to go all the way back to 7th grade, 8th grade, freshman year, last year. No, not kindergarten. Although some kindergartners might know how to solve, just not specifically. We need to use a proportion to set this up. One side is going to be your unit rate, or your rate of change, and the other is going to be your new equation. I have no idea, your new fraction, whatever. Okay, so on the left side, I need to create a fraction. What goes in the numerator? 0.065 what? Ooh, not miles per second. Just miles. Because remember, this word per gives me a what?
Oh, fraction.
Fraction. Then what goes in the denominator? 1 second. Why 1? Why is it 1 second? You just guessed? Yeah, the unit is per 1 second. Even though it doesn't specifically say per 1 second, we know it's per second. Per 1 second, right? Per one thing. All right, what are we looking for? Distance is measured in what? So then, which one of these will be a variable? Numerator or denominator? Numerator. Remember, you have to match up your units. Then what goes in the denominator? Not 60. 90. Because we're trying to figure out where it's at in 90 seconds. All right, how do I solve a proportion? Cross multiply. Did you guys say butterfly? Yeah, sure. So if x is equal to 5.85. Take us along. Maybe you need to go to the doctor then. This your final answer? What are my units? No. Just miles. Just miles. Because that's what we're looking for. We're looking for miles. What do you mean plug it in? Yeah, but it's not always going to be that way. You might have to divide it. Questions? Seniors? Are there any questions? Are we sure? Okay. Let's move on to number 2. Ellie wants to buy a new video game console that costs $260. So she gets a job as a dog walker and earns $10 per day. The rules are she can spend whatever money she makes in a week. At the end of each week, whatever money she does not spend, Ellie's parents make her put all the money earned into a savings account, which cannot be spent after it's in the savings account. At the end of the week, oh, son of a biscuit. Can you change this to week 4 and week 8? Sorry, that should be just week 4. Not 44. It should just be week 4. Not 44 and not 88. Brian. Ellie has 319s in her savings account. On week 8, she has 1,392 in her account. In the end, Ellie did not spend any of the money. Find the average amount she earns per week. So we need to figure out our units. What word tells me automatically? The fraction bar. Per. So that means that anything to the right is my x, anything to the left is my y. So what is my denominator units? What are my denominator units? Weeks. What are my units in the numerator? Amount. How is amount measured? What kind of money? Yeah. In what? In dollars. Okay? Got it? So it's going to be, what is the unit rate then? No. Just what are your units? Not your question. Dollars per week. Okay, now we need to create two what? What are these called? Coordinates. So somebody give me one of the coordinates. Anybody? 300? I can't hear. 319, comma 4. I saw somebody shake their head. It's the other way around. Why is it the other way around? What are the units of x?
Weeks.
How do you know that? Because what? How do we know that? We need to know how we know that. The units, right? And what's x is weeks. So we have 4 and 319. Are there any questions? Are we sure? All right, then give me the other unit, or the other coordinate. Very good. So do I have the information I can use to find the average rate of change? Yes. So we have 1,392 minus 319 divided by 8 minus 4. And you get a fraction. Right? No, yes, maybe so. Can we have fractions in word problems? No. So Miss Santana, what am I supposed to do? I have no idea what to do. I have no idea what to do. I have no idea what to do. Just divide. 1,073 divided by 4. Just divide. Put the fraction back in the calculator, but just divide normally. Okay? So that gives me 268.25. Will that get you full credit? What do we need? Units. What are your units? Dollars per week. You can write it like this. You can put dollars per week. Am I off screen? You can write it in words, dollars per week. I don't care. Can you give me 1 second? Hello? Hello? Sorry. Questions? All right, let's look now at the exam, or part B. Do these amounts prove that Ellie could have purchased the new game console in any of the weeks between 4 and 8? What? Yes or no? Why? Can you say that whole sentence louder? Did everybody hear that? One more time, louder.
She makes $268 a week, and it exceeds the amount of game cost.
So yes, because she makes approximately more money per week, or as Christian said, like whatever, like as long as it makes sense, than the cost of the console. Questions? Are we sure? No, you're not sure? Or no, you have questions? Good? Okay. Last one. The police have accused a driver of breaking the speed limit of 65 miles an hour. As proof, they provide 2 photographs. One photo shows the driver's car passing a toll booth at exactly 2 p.m. The second photo shows the driver's car passing another toll booth 21 miles down the highway at exactly 2:20 p.m. Find the average speed. What does the photo evidence? Does the photo evidence prove that the driver broke the speed limit? All right. So before I move on, we need to find our units. What are our units? Miles per hour. How do we know that? Because it says it. So we need to compare everything to this right here. Okay? So the change of y over the change of x will be what over what? Miles over hour. Okay. So we need to create 2 coordinates. What is the first coordinate? What is the first coordinate? It is not 1 and 21. It is not 2 and... Not 1 and 65. What did I say if they don't give you a starting... What? Half of that's right. 0, 0. When you don't have something, the origin, the starting point is 0, 0. We don't have a starting point. Right? They didn't say that he drove for an hour and then he was this many miles away and then after blah, blah, blah minutes, he was this many miles away. No. So if they do not give a starting point, what did I say you need to do? 0, 0. Okay. Next thing. We need to create a new, or the next coordinate. What is the next coordinate? Or give me one of the things in the coordinate. 21. Where does that go? In the y. Why does it go in the y? Because what? Because of the miles. Okay, good. Now what do we need then? What do we need? Time. Time is measured in hours here, right? Time is measured in hours. How much time has passed between 2 and 2 p.m.? 20 minutes. But we need it in what? Hours. No. Keep it as a fraction. What? No. How do I find it? If we need to multiply to go from hours to minutes, what do we need to do to go from minutes to hours? Divide. So we're going to divide by what? By 60. We're going to divide by 60. Oh, why did I erase that? This should say minutes. And that's going to give me 1/3 hour. So this is going to be my what here? Yes, but what's my x coordinate? Questions? Now do we have the 2 things? Yes. So we're just going to do 21 minus 0 over 1/3 minus 0 is equal to 63 63 what? Miles per hour. Questions? Questions? All right. Part B, does the photo evidence prove that the driver broke the speed limit during this time? Does it? Why no? Because what? It's under the speed limit. No, because the average speed was 63 miles per hour, which is less than the speed limit. Am I off screen? Yes, I am. Questions? Are we sure? Are we sure we're sure? No? No, you're not sure? Or no, there are no questions? You're not sure? Oh, no questions. Okay? All right, then, on the back, you have